Okay, 1.1b. Go ahead and write this down. We're going to look at a piecewise function. For x less than 1, we're looking at the equation 2x plus 2. For x greater than or equal to 1, we're looking at 2x minus 4. So go ahead and graph this, and we're going to go 3 out on each direction. Okay, so if we want to graph this, I'm just going to make a little xy table for each. So we have x and 2x plus 2, and then x and 2x minus 4 to make it easy to graph. Okay, for the first one, we're looking at x is less than 1 to use this. Less than 1, let's start off with 0 because that's very easy. So 0, 2. So I'm going to go over here in 0, 2, we're going to make a point. All right, another number less than 1 is negative 1. If we put a negative 1 in there, we get 0. Negative 1, 0. Okay, we know this is an equation of line. All right, but x must be less than 1. So what if x is 1? Okay, so we're just going to test. We know it can't be, but we're going to test it anyways. We're going to test 1. If we put in 1, we would get 4. That's how we know that we're going to go 1, 2, 3, 4. We're going to put a little hole right there because we're not including 1. We can't. It can't equal 1, so we put an open hole there. But to find where it is, this open hole is, we go ahead and put a 1 in there to figure it out. All right, so this is going to go in this direction. Very good. Okay, let's do the next one. If x is greater than or equal to 1, well, in this case, it can equal 1. So we're going to put 1 in here. 2 minus 4 is negative 2. 1, negative 2. All right. Another number greater than or equal to 1 is 2. If we put a 2 in there, 2 times 2 is 4, minus 4 is 0. So 2, 0. Okay, notice we have the same slope, so we will have parallel lines. Okay, but this arrow doesn't go down here. Why doesn't it? Because anything less than is going to be this equation. So we have to stop there. There we go. So now you can clearly see x less than 1, here's 1. This represents x less than 1. X greater than or equal to 1 is right here. Greater than or equal to 1 represents this line. Okay, so now let's look at the limit. The limit of f of x as x approaches 1 from the left. Okay, as x approaches 1 from the left, here's 1. Here's, where did I go? As x approaches 1 from the left, sorry, here's 1. We're approaching 1 from the left, and where is it headed? It may not get to 4, but it's headed to 4. That's why we say it approaches. So as we get closer to 1, here's 0, here's a half. So as we get closer and closer to 1, f of x is going to 4. Okay, let's look at another one. The limit as x approaches 1 from the right of f of x. Okay, so we're looking at 1 and we're approaching 1 from the right. So from the right, we get this in here and we're getting closer and closer. And where is it going? That's right, it's going to negative 2. Okay, let's do a new one. F of x equals 3x minus 3 over x minus 2. What do we know x can't be? That's right, x cannot be 2. So if x cannot be 2, we know the vertical asymptote is going to be x equals 2. So we're going to make a new graph. I'm going to erase this graph now and make a new one. Take this off. Okay, gonna make a new graph. We just said the vertical asymptote is at 2. So there's 2. I'm going to make a vertical asymptote, and that is the equation x equals 2. Okay, the horizontal asymptote. Here we have x has the same degree, so we're looking at 3 over 1, which is the coefficients, which is just 3. So we know y equals 3 is the horizontal asymptote. 1, 2, 3. Didn't want to run out of room. Okay. All right. So without plotting this all together, I'm going to show you what the picture looks like. It's going to look like this, where it's getting closer and closer to those asymptotes. And over here, it's going to look like this. Okay. So what I would like you to do now, I call this in your groups. Usually I teach this and people are sitting in groups, but you're not doing that. You're by yourself. You're welcome to talk to someone else in the class if you want on this. So what I would like you to do is answer these questions. The limit of f of x as x approaches infinity. Go ahead and do that one. And here's another one. Okay. I'm going to erase this to write some more. Okay, so I'm giving you 5 questions to do on your own, and we'll go over them. Just want to make sure that you're understanding what we're talking about. X approaches 2 from the right. Okay. The limit. Okay, I'll give you a moment to do that. Okay, let's see how you did. The limit of f of x as x approaches infinity. So here's infinity. As x approaches infinity, f of x is heading towards this line. And what is the equation of this line? We said it was 3. That's right. So this is 3. All right. The limit of f of x as x approaches negative infinity. So x is going to negative infinity. And where is f of x going? It's also heading towards that line, 3. Okay. Now let's look at the limit of f of x as x approaches 2 from the right. So here's 2, and we're approaching 2 from the right. Now 2 from the right, we can see f of x is going to positive infinity. And here's 2, and as we approach 2 from the left, this is going down to negative infinity. So, the limit of f of x as x approaches 2, does it exist? No, it's undefined, D and E.